I am many things, and Thorsten Ball is one of them. As YK said, I work at Sourcegraph on AMP, which is our AI coding agent. And today I want to talk to you about subagents. And the title here, Subagents and the Multiplication of Context Windows, sounds super complicated, but it's really not. I want to leave you with one idea, maybe one and a half. And I can start by saying that if you have heard about subagents, this is not going to be a talk in which I say they're the solution to all of the problems, but I do think they're pretty interesting. And they're pretty interesting because they change our relationship to this, which is the context window. I think most of you here know what a context window is, right? Short recap is, if you talk to a large language model, their basic job is to complete text. So you send up a bunch of text and you want it to complete the text either by adding a new message or by completing the line or a sentence or whatever. And all of the text you send up and all of the stuff you get back down from the model has to fit in the context window. But you think of the context window as something abstract, like this is where the text goes and stuff comes out. But when you work with agents, the context window is actually where everything ends up. Every user message that you send, every assistant message that comes back from the model, every tool call, and every tool call result, right? So if you look at this in practice, I can show you real quick. If I say have this app open here, which is like a funny, maybe not funny, but it's a toy app, and I can say, can you make this look funnier, or something like this, right? And what's happening now is the agent says, I'll need to see what you're referring to first, and it reads, it makes a tool call, right? And then it says like, let's say here, the landing page or the main page. It sends back messages, I send back a message, and then it makes a tool call. And you can see in the bottom right, I don't know if you can see it actually, but I hope you can see it. It says 7%, now it jumped up to 11%. It says we're using 18K tokens out of the 168K tokens available to us. Because we're using Sonnet 4 right now in AMP, and we have a 200K context window, 32K are reserved for the output, so we have 168K tokens available. And the more tool calls you see here, the more the context window fills up, okay? That's one of the ideas I want to leave you with, right? Because if we go back to the slides, this is actually that stuff that shows up in the context window. So up here it says what I wrote, a version of it, can you make this app look a little bit more fun? And then the assistant says like, yeah, I'll help you make this look more fun. And it sends 3 tool calls down, right? Now AMP is ready. This is our, the agent is ready sound. So here it made it funnier. But the tool calls end up in the context window. The results end up in the context window. And the problem is sometimes the agent goes off the tracks, right? And it looks at a bunch of files and it looks at a bunch of stuff. And what ends up happening is maybe we see this bad message down here where it says context window limit reached because the agent looked at too many files. It read a bunch of super long files or ran bash commands that produce a lot of output. You run out of tokens. Or even worse, you end up with this, you know, where you say, oh no, and it says, you're absolutely right, I have to fix this. But the point is, the context window is precious, right? And it can fill up with garbage. It can fill up with tokens that are not that important because once you run out of tokens, what most of us do, I think, is we go back and we look, what's the important stuff in this conversation? Let's copy this over to a new conversation. Or we use something called compact, which is a feature that a lot of AI agents have, which basically summarizes the conversation, which is lossy. It compresses stuff. You get loss of signal. And then you put this in a new context window. Point being, some tokens are more important than others. And some tokens are just garbage and they fill up the context window. It would be nice if you can get rid of them. So I want to show you something else. Look at this prompt here. Where do we check the authentication headers in the server? Use the search agent. Let me run this. So I'm running this in our AMP repo. It's pretty hard to type on this table, to be honest. So here I'm being explicit. I'm telling it to use the search agent. I'll explain to you in a second what this is. But what it now does is it makes a tool call. And this tool call actually invokes another model, another agent that has a separate context window. And as you can see here, it searches for a bunch of stuff in parallel. Even it uses grep and it searches for different regexes and tries to find out where the authentication headers are. It then reads a bunch of files that it suspects contain the answer to the question. It reads some more files. It reads, I think in this case, it reads multiple portions of the same file. Reads another file. It says, let me find the middleware. it goes on. Like this is, I don't know, I'm eyeballing it, but let's say 32K tokens. I don't know. I cannot prove it to you, but let's just say it's a lot of tokens, right? The point is, once this is finished, which hopefully we'll see in a second, but this is a live demo. So now it's finished. And what happened is the search agent comes back with only this reply here. This is its result. This is the result of the tool call. All of the other tokens, all of the garbage tokens that fill up the context window, they don't show up in our main context window, because if you look down here, we only used up 13%, 22K tokens, for one tool call with the result of where something is. If we look back at this here and switch to this diagram, this is what we just saw. The main agent, that's the one on the left, with a conversation with the user and assistant, and then there's a tool call, and the tool call calls a subagent, which has a new context window. 200K tokens free to use for the task of finding something. And in this context window, the main agent acts as the user, which is why this is in quotes up here, top right. And then the assistant makes a bunch of tool calls, and at the end it comes back with, here's what I found out. And in the main context window, only the last result ends up in the main context window. So I don't know how much you've done with searching or agents, but I think this is a pretty interesting idea. You get a new context window out of which you can pull some information, and your main context window doesn't fill up. And obviously you can do this with more subagents if you have more tool calls, and you can see where the title of this talk comes from, the multiplication of context windows. The more tool calls you have that invoke subagents, the more context windows you have. Again, I'm not saying it's a solution to all of the problems, but it's pretty interesting. And we've seen this a lot in practice, that it saves a bunch of tokens, and stuff where the agent without subagents would lose, say, 50K tokens, which are worth something, are now being used by the code-based search agent, right? So that's the one thing. We get with subagents a new context window, or multiple context windows. And then there's another thing we have in AMP, which is called the oracle. If there's lawyers present, I want you to know this is all lowercase. It says the in the front. We do not refer to the software company called Oracle. But we have a subagent called the oracle. Let me show you to you what it does. So this is a pretty, let's use this here. So again, I'm explicitly asking our main agent to consult the oracle. And what's happening now, and this is probably the most exciting part of this demo, because I don't know how long this will take, because under the hood, the oracle is powered by O3, OpenAI's O3, which is a pretty smart, pretty good at reasoning model that's also pretty slow. But this is now a context window where the quality is different. It's not just the quantity now of the context window. We have a different context window with a different quality because it's filled by a different model, right? So now O3 is going to look, it also is an agent, it also has access to tools, it can also search for stuff, it can also read files, and it can also look at, a bunch of other files. I don't know if this will do it, maybe it goes wrong. O3 is not the greatest at calling tools, which is why we don't use it as the main agent, even though others sometimes ask, like, why don't you use the smartest model for the job? But in this case, I don't know, let me see. I want to show you, maybe I'll show you, let's see if this runs. While this runs, let me show you something here. If I can pull this up. So at ampcode.com, this is what we built. You can see my threads. Oh, there you go, it's done. Oh, sorry, this was good. I'm mainly here to demo our identification sound. But here, O3 came back with this result, right? It says high-level purpose, blah, blah, blah. This is a self-contained ink program, blah, blah, blah. And here's O3's formatting and whatnot. And here again, like it's this same thing where only this stuff here will end up in the main agent's context window. We only used up 25K tokens. I think this is only this reply. But it's not a lot of tokens, and we get O3 for free, running in a separate context window, right? So that's another angle here. So we have subagents that have a different context window with a different quality. Then we thought subagents are cool. How about we give them also access to write tools so they can modify files on disk, right? So let me show you this. This is the next prompt here. Use 5 subagents to remove comments through from the files in post. So this is in my blog, and we can say use 5 subagents to remove comments true. Also, side note, When I write prompts, I always use backticks, and people laugh at me, but I think it's important. I don't know if it does anything, but I think it. When I'm live on stage, I think it counts.
I think it's important.
Yeah, it is, yeah. Was this the prompt? To remove come through from the files in post. From the files in posts. All right, look at this. So this will now use 5 agents to remove comments through. This is the main agent. It now looks at how many files we have. It lists the files in this directory. This is my blog. And you see I haven't written a blog post in a bunch of years. And now it will distribute the files across 5 subagents to remove comments through from each post. I didn't tell it to distribute this. I didn't tell it to what files goes in what. But you can see here, if I open this, in each of these, we now have a full agent. That's the main agent inside the little box, running and editing files, right? Without taking up context window of the main agent. And if you've done anything with agents, you know that they sometimes fail to edit files, or they fail to run bash commands or something, and they run into errors, and it sucks up tokens, and it's frustrating. And you can actually shove this sometimes into subagents, and the subagents will do the dirty work of trying to implement something, and it won't affect the main agent's context window. And that's what happened here. It successfully removed it from 24 files, all of which have been read, and it only used up 9% of the context window. And I think that's pretty neat. And this is what I want to leave you with. This was all it was. What else can we build with this, right? The idea is, what if we have multiple context windows? We can spawn subagents, as we've just seen. We can use different models for different context windows. Can we merge information from one context window into another? Can we freeze them? Can we reuse them? Should we be able to split them up and only reuse parts of them? Can we, I don't know, always have fixed context windows that are frozen and always cached, and we can reuse them across the same code base? I think there's a lot to do, and I hope that this gives you an idea of, there's still a lot of unexplored stuff, and most of it won't work, but some stuff will work, and I think it might be magical. All right, that was it. Thank you so much.